Hello everyone. So we are doing a project on diabetes prediction. The project aims to utilize diabetes prediction database, compromising, comprising the diverse medical and demographic information like age, gender, BMI, hypertension, heart disease, smoking history, and etc. The goal is to build machine learning models that predict likelihood of the diabetes based on individual health histories. Now let's talk about the primary objective of this. Firstly, early identification of individual at risk of diabetes for timely intervention and personalized treatment plans. Secondly, improving healthcare by providing accurate predictive tools, enhancing patient care, and enabling proactive diabetes management. Now let's talk about the motivation regarding this project. Firstly, addressing critical need for enhanced diabetes management and prevention strategies due to condition chronic nature and severe health implication. And secondly, facilities research by exploring complex relationship between medical or demographic factors and diabetes development, contributing to a deeper understanding and more effective preventive strategies. Overall, the project aims to bridge clinical and academic domains, advancing both the understanding and management of diabetes for better patient outcomes and improve public health strategies. Nextly, my fellow member Martisan is going to describe more about this project.
Hello, my name is Omrit Sarnivi. I'm going to talk about the dataset description. First, we take a variable name data and we import the CSV file into it. As we can see, we have 100,000 different samples or instances, and we have 9 different features. And between the features, we have two types of them. They are categorical and quantitative. The categorical features are gender, hypertension, heart disease, and smoking history. And quantitative features are age, BMI, HbA1c level, and blood glucose level. Now we are going to talk about the correlation between these features. The correlation between these features measures the strength and the direction of a linear relationship between two variables. A positive correlation that is close to 1, it means that a strong tendency for both the variables to move in the same direction. Conversely, if we have a negative correlation that is close to -1, it suggests that a strong tendency for the values to move in the opposite direction. Again, if we have a correlation that is close to 0, it implies that no linear relationship between the variables is there. Now we are going to talk about the imbalance data set. As we can see in the gender feature, the classes male and female have significantly different instances. While the female has around 58,000 instances of diabetes, but the male has 41,000. Here we can see the difference in the data set. Also, the smoking history feature also demonstrates different kinds of values for different classes. If you can see the density here, we can see that in the around the age 80, we can see more instances of diabetes. And we can also see the instance of the diabetes is also not equally distributed, which means the database is likely to be biased. As a result, it can be concluded that the unique classes for the features do not have an equal number of instances.
Hello. So for our dataset reversing, we do have 10,000, 100,000 dataset, and in the dataset we don't have any null values, but we do have some duplicate values which are around 3,800 samples which are duplicates. And the second fault, we do have that in our dataset the smoking history and the gender. These are the categorical samples, so which are incompatible with our prediction models. Third fault in our dataset, which are these are that ages like age, BMI, HbA, blood glucose. These are the values which are very high and low. So we do have so these are the third problem in our datasets. So how can we solve them in our pre-processing? So let's see it. So first of all, we first check in the dataset we do have a null value or not, but there is no null value, and then check that there is any duplicate values. There are around 3,000 duplicate values. So in the error handling part, we have to do that, drop that duplicate things. So after dropping the duplicate, we do now we have around 92,554 samples. That's how we solve the error handling part. And then second problem, we have that that categorical instance, the smoking and the gender. So for these things, we are using that encoding. So what encoding does, encoding do that encoding do the convert the categorical into the numeric levels, which helps to increase the computation power for our models. So we select that smoking history and the gender and convert into the numeric things. That's how we solve our second fault. For third fault, which are that our BMI value, HbA, blood glucose, hypertension, age. These are the some values which are some of them very high and some of them are very low. So it creates some problem to our models. to ensure this kind of feature that with different scales don't dominate the model training process and needing more stable and accurate models, we have to do that feature scaling. So in this part, uh, we do our feature scaling so that all the unstable data and the with different scales we convert into some standard number, so it will help to better training in our models. And the fourth and the most important part of the preprocessing is the uh, test and split. So for test and train split data set, we 30% data to the test part and the 70% data to the train part, and we do the random state so that uh, it will help us to the reproducibility of our dataset.
Hello, my name is Shahan Ujjulani. I'll talk about model training and testing. So, in order to improve the effectiveness of the various classification models, as we're training such like logistic regression, KNN, decision tree, random forest, we are employing like a five-fold cross-validation technique. We actually use this because in order to we need to provide a reliable estimate of their performance. For distinct classification models are initialized training assessed several times. Several times means like 5 times. We actually did this like 5 times. And to maintain consistency throughput, the 5 training and testing cycle, each model is tested using the same random state. Each model is trained and tested on same subset of data because we use the same random state for both training and testing. By doing this, bias that might develop from using different data subsets are avoided and a fair comparison is facilitated. This model accuracy, precision, recall, and F1 scores are calculated for each run to each run on the held out test set on obtains a more stable and trustworthy estimate of model performance. So by averaging, here we actually did average. There's 5 times, and for averaging, this make it possible to choose the model based on performance with greater knowledge. So all four models' final performance output is right now here. Here you can see that accuracy. These are actually the average or the mean value of the 5 times loop. Then, if we actually compare the precision and recall for each model, uh, we did talk about I would like to talk about here the decision tree, as this model has the highest recall, like 62% more or less. Then precision is 58 19%, and suggesting that it is proficient at identifying most positive instances, although it has slightly lower precision compared to the logistic regression and KN models. But in case if we look at random forest, this model actually achieved the highest precision, like 92% more or less, and a reasonable recall, which is like 54%, meaning that it correctly identified a high portion of the actual result and also somewhat captured a moderate proportion of the actual positive instance. Now, if we compare the accuracy, we can see that here we actually showed the bar chart with an accuracy of 96.91. The random forest model outperformed the other models in this instance, suggesting that it classified the instance with the highest accuracy. With a 95% accuracy rate, the KN model came in close second and did a consistently good job of forecasting the result. Although the logistic regression model and the decision tree model achieve accuracies of like 95 and 94% respectively, showing good performance but slightly lower than the random forest and KN model. Then if we look at the confusion matrix, and here we can say that in the code, once the grid star is complete, the base set of parameter for the random forest model is obtained using the estimator. After the base random forest model is obtained, a confusion matrix is visualized using the confusion matrix display method. So if we talk about this confusion matrix of logistic regression diagram, we can see that this model correctly predicted like 801 instances as positive, which means that there is somewhat presence of diabetes. And the model also accurately predicted 25,821 instances as negative, means there is the absence of diabetes. Also, if we look at the model incorrectly predicted 202 instances as positive when they were actually negative, but this model unfortunately missed 939 instances that were actually positive. But if we see here the other more of a random forest confusion matrix, we can see that it actually correctly predicted 964, which is good, and it did somewhat missed uh, 776.
As my fellow member described the project, so we can come to a conclusion that A number of machine learning algorithms, including k-nearest neighbors, logistic regression, random forest, and decision tree, have been used by our diabetes prediction project to predict an individual's risk of developing diabetes. Following careful examination, it was discovered that the random forest model outperformed the other models, achieving the highest accuracy at 96.91% and the highest precision at 92.35%. Well, this demonstrates how well risk factor relationship and their impact on diabetes prediction are captured by the random forest. Because of the random forest superior accuracy, healthcare professionals can use it to identify people who are most likely to develop diabetes, make well-informed decisions, and take targeted preventive measures. So this is all about our project. Thank you.